Hey everybody, welcome to Weld Fever. On today's episode we're going to be dealing with a little flux core, and I'm not just talking about 211, I'm talking about the big stuff, 232. So stick with me, here we go. Okay, to begin this lesson, I have a saying that I like to tell my students, and that is, the game is won or lost at the beginning. So probably one of the biggest problems is not setting their machines correctly. So based on that, I'm going to go ahead and discuss some of the machine settings here so that we're all on the same page, okay? So let me go ahead and zoom in here, and hopefully you can get this. And so I'm going to get in here nice and tight so you can see some of the stuff that we have here on this particular machine. Now Lincoln makes a comparable machine, and I believe their settings are close. I've used one on a couple of occasions. I can't really remember, but I'm pretty sure that their settings are going to be really close to this. So hopefully this will help you Lincoln users as well. Okay, first of all, down here at the bottom we have our wire speed, okay? Up on top here, this digital readout will tell you what your voltage is, okay? Very simple, and here you can see A for amps, V for volts, alright? Up here is your power switch, no explanation necessary there. This is your hold switch, and this one, what it'll do for you is if you have the hold switch engaged, when you press the trigger on the flux core gun, it will continue to dispense wire. It'll keep rolling that wire out, and it won't stop until you depress the gun trigger again. So you got to be careful with that one, because if you don't realize that one is on and you don't have intentions for it to be on, you can end up with a little bit of a mess, alright? Finally, here we have a purge button, and what that basically is if you're running this machine with shielding gas and you're done for the day, rather than having to depress the trigger and roll some wire out in order to purge the gas, you can just go ahead and click on this, hit this one, and as long as you maintain it depressed, the gas will purge out of the system. So yes, and by the way, speaking of which, you can use MIG wire on this. You can use dual shield, which is a type of flux core that also requires shielding gas, and of course you can run regular flux core as well. Okay, so now I have actually opened the machine up. As you can see here, here is the side of the machine, and I just go ahead and open up the lid, and this is the internal components of it. As you notice, there's the spool of wire and there are drive rolls. Really, this setup is no different than any other type of MIG welding machine or flux core welding machine. Just remember, if you're going to weld with flux core like we are today, that you should use a knurled drive rolls. That would be the drive rolls right here. Now we're going to talk about these three buttons that are on the inside here. They're actually very simple. The first one is a soft start, and basically what that does for you is when you first engage the trigger, it actually slows down the wire speed. So it makes it very easy to begin the weld. When we're dealing with this 232 stuff, it's usually very, very hot, and some people have a hard time getting it going. So this soft start is meant to help you with that. Second of all, we have the high-low. Basically, it just determines where the scale of the wire speed is going to be on the indicator. So if you have it in the low setting, it will allow you to fine-tune the lower wire feed speeds, and it will just display lower wire feed speeds. And then on the high speed setting, it goes from like the lowest is 200 all the way up to its maximum, which is up there pretty high. So that's basically all this is for. So if you need to make fine adjustments at the lower end, you should be on low. And if you need to really crank it up high and you don't want to sit there and spin the dial forever, then you can hit it into high and get it up there really quickly. Finally, we have CC and CV. It stands for constant current and constant voltage. This is related to the power source that's going to actually power this suitcase welder. The ideal and the best way to do this, all MIG and flux core, is on CV, constant voltage. That's the kind of power source you want to use on a MIG welder. Now this has the ability of being able to switch to a constant current power source if that's all you have, but even according to the manufacturer, it is not an ideal situation at all. So you want to make sure that you definitely, if you can, use a constant voltage power source and not a constant current. because in theory it's supposed to work, but if they're cautioning you against it, what chance do we stand, right? Okay, finally we have a fuse here and a little reset button on the end in case you overheat the machine, and hopefully that won't be a problem. So now I'm going to discuss the power source for this. I actually use this two ways. Here in the shop I use this Miller XMT 304, which is a DC inverter arc welder. It's a multi-process machine, which means I can connect all kinds of goodies to it. I'll go ahead and open up the hood here so you can see and zoom in on this just a little bit. As you can see, it has different processes available here, and one of them is a voltage sensing wire feeder down here below. That's the setting for this particular machine if we're going to use it. But on this one you can also stick weld, MIG weld, even TIG weld, do some lift arc or scratch start TIG, although you would need a TIG torch with a valve for shielding gas, because there is no solenoid built into this particular machine. Anyhow, I also use an engine drive when I'm in the field, which I have, an engine drive generator. And so these are the two ways that you can power this wire feeding machine. Just like everything else, we definitely have to use a work clamp. Some people refer to this as a ground clamp or an earth clamp, but this is definitely going to have to be used in order to complete a circuit and actually make a weld. But in addition to this, we also have this little voltage sensing clamp here. This is an integral part of this kind of a system. Without this, the machine can't sense the voltage, and it actually won't operate if you don't have this connected. So you just basically have to clamp this to your workpiece or your table, whatever the situation is, and everything will go just fine. Now, unlike traditional MIG welding or even flux core welding with a MIG gun, this system, NR232 in 0.072 diameter, requires much more heavy-duty equipment than what we're used to. And so this here is the gun that we're going to use in order to make this happen. This is a flux core gun, heavy-duty, as you might imagine. If you can see here, the diameter of this wire is quite large. It's 0.72, larger than anything we've dealt with on the show, that's for sure. And as you can see, this type of gun is much different than your standard MIG gun. First of all, it has this shield on it in order to protect your hand from the intense heat that this radiates outward. And this entire gooseneck here is actually made of copper that's lined with a special liner in order to keep it from melting. And then we have, you know, typical to all MIG and flux core welding, we have a contact tip at the end. And then we have this protecting shroud here that protects the actual end of it and the threading and whatnot. So it's a very different type of a gun, but it's definitely necessary for this type of hot process. Alright, so before I get too far into this video, I guess I should probably talk about what this process is for. NR232 was designed for heavy structural welding. Anybody working with heavy iron, and a lot of it, is going to be using this 232 wire. Most people refer to this type of wire as the NR232, but it's actually an E71T-8 if I'm not mistaken with AWS. I might be wrong on that, but I'm just throwing that out there. And there are other manufacturers that make it. Hobart has one called Accelerate. ESAB has another wire. They all have different characteristics, very slightly. But what you'll notice on this particular wire is, number one, the diameters that we're using are much larger. We're going to be using a 0.072 diameter, which is up there, very thick. Although the wire feed speeds that we're going to use are lower than traditional MIG, the heat of this is much more intense. So you're going to see this as we go. Also on NR232 especially, the slag system on it is very thick, and as a result sometimes difficult to control. That's what gives most people a problem on this. I will say to all of you out there in YouTube land, if you're a hobby welder and you're not welding structural steel, especially not for a living, this is probably not something that you're going to ever really need or even want to get into. It is kind of a pain to learn, and it takes a very long time. but it may be interesting for you to know that this exists if you didn't. And at the very least, you'll get us a kind of a new handle on something different here. And for those of you who are intending or are in structural, then this will be old hat to you. A lot of welding students get into this doing 232 because they have intent to go and become iron workers or whatnot. And I get a lot of requests for this all the time. In fact, just recently I visited a school, and I had one of my viewers recognize me and say, "Hey, when are you going to do a video on 232?" In all honesty, I decided, you know what, it's probably about time. I've been thinking about it for years, so this is the one we're going to do. So anyway, let's see how it goes. Okay, so let's get this thing starting here. To begin with, let me say that our wire feed speed is set at 155 inches per minute, and we're at 21.5 volts. We're using Lincoln NR232 at 072. Now notice the very short stick out that I have when I first begin the weld here. I want to make it very clear that when you first start a weld, you should have a short stick out like that so you can get things going. However, once you get going, the stick out on this type of material here, this type of wire NR232, is quite long, and you should pull back and be at about 3/4 of an inch to 1 inch stick out. You'll notice now that I finally raised it back up. It's kind of hard to see how long it is because of all the smoke, and I do have my fume extractor running and it's trying to pull it out there, but this is an extremely smoky process. I will also caution you that the stuff that's in this wire is very bad for your health. You do not want to inhale it, and in fact, if you do, you're going to find yourself coughing like crazy. I don't know exactly what's in it, but it makes you cough. So you must wear a respirator when you use this stuff, or at the very minimum have very good ventilation. We're talking a fan blowing the other way, out of your way, or else like I have a fume extractor. Okay, I didn't really get a chance to talk too much about the process, but as you noticed, I'm not really holding the sides here. A big mistake that people make when they first start doing this type of wire is they try to hold the sides like they would with, say, an E7018 SMAW electrode. You absolutely cannot do that on this. You have to just wash over the sides and move out quickly. And the reason for that is you're trying to stay ahead of the slag the whole time. This slag, if you take a look at it, I'm chipping it off and it's coming off really nice, but look how thick that stuff is. It's extremely thick, and if you don't stay ahead of it, if you don't keep it at bay, this stuff will overtake you and you will have slag inclusions. Slag inclusions are very, very easy to come by in this process, so you really have to watch out. You'll notice that when I was welding, I was moving relatively quickly, and that's so that I can wash the side and wash the other side and just move. You do not want it to build up, and you do not want the slag to make its way around and in front of your path of travel. It's going to want to do that. It's going to want to creep on you and come around and get in front of you. You cannot allow that to happen at all costs. And what I usually do to prevent it is to give it a little wiggle to keep it at bay. And you will find that wiggling a little bit as you move side to side will help to keep that slag out of your way. Okay, I want to take a minute to look at this weld since it's something new that we haven't really seen before. Take a look at just how wide it appears. Now, I will say this. You should not make a bead any wider. It's suggested by the manufacturer no wider than between 5/8 and 3/4 of an inch. So I guess 3/4 of an inch would be your widest. I will say that we're right on the edge of that here. I know it appears to be much larger. It's because it wetted in so well and fused so well to the bead next to it that it almost appears like it's just one giant bead from certain angles, but it's not. It's actually at least two beads there, and one is a little wider than the other, but that one's probably right at the max of the 3/4 inch limit. Any larger than that and you're actually going to have to be weaving this stuff, and I will say that the manufacturer does not recommend that you weave NR232, so you have to run essentially stringers on this stuff to be successful. On this next pass, let's go ahead and talk about technique here. As with most welding, what I recommend is that you hold the electrode at about 10 to 15 degrees and the direction of travel away from 90. So you're going to cock it back a little bit, about 10 to 15 degrees is fine. That way you can keep the slag in front of you and not allow it to get in front. Now you'll notice that there's a lot of movement that I have here as I go, and I talked about this before, and this is kind of that wiggle action that I mentioned. It's not exactly a weave, it's almost like I have an unsteady, shaky hand, and I do that on purpose because I'm really trying to keep the slag at bay. A very important process in this whole 232 is trying to keep that slag from coming up around in front of you and trapping it underneath. So if you notice a lot of movement, that's why. Also, look at how cherry red and hot this is. This stuff is really, really hot. You're going to have to definitely shield yourself from that heat at all times, and that's why the guns have that piece of shielding on it. Notice how nicely the slag just peels off here when you get everything dialed in correctly. When you have the right travel speed, the right wire feed speed, and the right voltage, and your stick out is correct, and everything's going well, the payoff of that is that your slag will just peel right off of your plate. And it's usually a pretty good indicator that you probably don't have any slag inclusions or any trap slag, because if you did, it'd be a little bit more difficult to take that off. So that's usually a very, very good sign. Okay, starting up on a next pass here, we're going to go ahead and go right next to it. Again, notice I am not holding the sides at all. I'm going very, very quickly. I jumped right through this one because we've already seen it, so I just wanted to show you real quick how I'm just really moving, and look at that nice payoff again. The slag came right off. But now let's talk about what happens when you don't have a nice payoff. Here we go. I'm going to purposely do something to demonstrate how delicate this stuff can be. Number one, you need to make sure that your material is very clean, okay? You got to take all the mill scale off it, make sure there's no dirt, rust, anything on there. It really requires it. Almost as temperamental as TIG welding, believe it or not. Second of all, you got to make sure your stick out is definitely that 3/4 to 1 inch. Now here, on purpose, I want to show you what happens when you don't do things quite so right. So I've tried to keep the stick out below the 3/4 of an inch. In addition to that, I've also sped up my travel speed, and I'm going way too fast. Now, there's two problems that are going to occur here. Usually when you increase voltage, you end up with these really bad, what they call chicken tracks, which is kind of a form of porosity. And also when your stick out is too low, you'll get those as well. But more important than that, and what I really want to show off here, and keep in mind, I didn't change the settings at all. The wire speed and the voltage are the same. The only thing I've done here is, number one, I have made my stick out way too short, and number two, my travel speed, I increased it dramatically. And as you notice, that slag is not peeling off like it did before. It's given me a lot of trouble. I'm having to hammer it, and it's not looking as nice as before. And now you notice here, as we're starting to grind this off, you're going to notice in the front, it's going to have this appearance. The slag is going to look like, and there's a close-up of it, looks like sand has been deposited on there. Now what happens here, this sand occurs for a bunch of different reasons, but usually the usual culprit here is the fact that the puddle was not allowed to get hot enough, and so it was too cool, too cold. I have to assume that because I move so fast here, that is why this slag stuck. And you won't get this off. I mean, I just hit it with wire wheel and it just stayed there. You know, you can try to chip it and bang it forever, and it just won't come off. And look at it there. It's just very, very doesn't look good, and it's not going to be good for your weld either. Look right below that there too. You're going to see those two little lines. That's some of that, those chicken tracks that I described earlier. That's as a result of my stick out being in there too short. And so if you see here, that's the stick out I had, and I just increased a little bit. That's what you want, 3/4 to 1 inch there. So just definitely make sure that you try to avoid this at all costs. Keep your travel speed fast, but not so fast that you're blazing across it and you don't allow it to get hot. In addition to that, make sure your stick out is correct. Okay, now we're going to change it up, and now you can notice, you can even see it here, that my stick out is much longer than it was before. I was like practically right on top of it, and now you can see that I'm up there. It almost looks like a full inch. At least that's what we'll estimate. And also notice that I'm going back and forth. I'm not, of course, I'm not holding the sides like I would with a SMAW electrode, but I am going side to side. But I am not moving across this plate nearly as quickly as I did before. Now, I'm going to be careful here because I don't want you to get the idea that I'm taking my time, because clearly if you watch this, and by the way, this is in real speed, this has not been sped up at all. So if you're watching this, you can see that I am moving across much quicker than I would for, let's say, a 7018 SMAW electrode. However, there is a limit, and if you do go too fast and you're watching your puddle, which you have to do, and you're seeing that your puddle is not liquefying correctly, that you're not fusing well, then you know that you're not tying into the sides, and you know that you're going too fast. And so you have to watch for that. That's the most important thing. You have to really keep an eye on your puddle to notice what's happening. So now let's take a look how this slag comes off after we did things correctly. Hopefully it just peels right off, and look at that. Peels right off, and a nice flat weld as a result. Perfect, that's what we want. So here are my recommendations to beginners. Number 1, clean your material thoroughly before you start. Number 2, don't skip steps. Start in the flat position and work your way up to vertical and horizontal. Do not start on vertical and horizontal. Number 3, make sure to visit the manufacturer's website, choose a wire speed and a voltage, set your machine, and do not change it. Work on your technique. If you're having problems, I guarantee you it's going to be your technique, especially at first. Try to resolve those technique issues before you change settings. Wow, that was a long one, but anyway, we got through it. I hope this satisfies all of you out there who have been requesting this, and proved interesting for those of you who hadn't. Keep your eyes peeled. We're going to probably continue along this theme, and I'll be doing maybe some horizontal and vertical at the very least. Hey, make sure to check out our website, www.weldfever.com, and check the store. We're going to have some new stuff coming up, including some shirts like the ones I wear on the show, and maybe some new stickers too with the new taglines on them. So thanks for watching, and we'll see you next time. Bye-bye.